For question 1, the median is halfway between those two observations and we're given is equal to 10. Therefore, 8 plus j over 2 is equal to 10. And if you solve for j, you'll find that j is equal to 12. Now the mode is equal to 18. And you can see from the data that the most frequent observation is k, the two k's at the end. Therefore, k is equal to 18. Finally, the range is equal to 13. Therefore, the maximum value, which is 18, minus the minimum, which is h, is equal to 13. Therefore, h is equal to 5. For part of question 2, I'll start with the third line. Now to plot the line, I'll create a table of x and y values. Now I'll put 3 random x values, 0, 3, and 6, and use the formula to calculate the y values, which come out to be 1, 4, and 7. So now I'm going to plot those 3 points and join them using a straight line. The other 2 lines are straightforward. Y is equal to 2 is a horizontal line cutting the y-axis at 2. And x equals 6 is a vertical line cutting the x-axis at 6. Now for part B, y greater than or equal to 2 means I want the region above the line y is equal to 2. X is less than or equal to 6 means I want the region to the left of x equals 6, and for y less than or equal to x plus 1 and the region below the line y equals x plus 1. So now I'm going to shade my region and label it R. For question 3, I'll use the formula speed equals distance over time. Speed is 820, distance is unknown, and now my time is 9 hours and 36 minutes. Now be careful, this is not 9.36. 9 hours and 36 minutes can be written as a mixed fraction. Now you can simplify this one as 9 and 3 over 5, or you can even write it as a decimal 9.6. I'm going to use the mixed fraction form, and if I cross multiply, my distance will be 820 times 9 and 36 over 60. Note there's a button on the calculator dedicated for mixed fractions. Use that one, and if you do, you'll get an answer of 7,872 kilometers. For question 4, I will rewrite the left-hand side. Then I'm going to change both fractions into improper ones. So I've got 18 over 7 times 28 over 9. Now I can simplify the 18 with the 9, and I can also simplify the 28 with the 7. So this will give me 8 over 1, which is equal to 8, which is equal to the right-hand side. For question 5, sine of angle 34 is equal to the opposite over the hypotenuse. If you cross multiply, x equals 6.5 sine of 34. Put this on the calculator and you'll get an answer of 3.6. For question 6, I have a speed of w meters per second. This means I have w meters over 1 second, and I need to change this into kilometers per hour. Now, to change meters into kilometers, I will divide this amount by 1,000. And to change 1 second into hours, I'll divide by 3,600. That's 60 squared. Now I will simplify by multiplying both top and bottom by 3,600. In the numerator, 3,600 divided by 1,000 will give me 3.6 W, and those are kilometers. And in the denominator, if I have 3,600 divided by the same number, I will be left with 1, and those are hours. So finally, I get 3.6 W kilometers per hour. For question 7, I'll split this shape into a trapezium and a rectangle. Now the area of the rectangle is equal to base times height. So I have 21 times 13 is equal to 273. Now the area of the trapezium is the following. And if I subtract the whole area minus the area of the rectangle, I'll get the following. 390 minus 273 is equal to 117. Therefore, 1 over 2 times 21 plus 15 times the height of the trapezium, which is x, must be equal to 117. So if I expand the bracket, I'll get 21 plus 15, that's 36, times a half, 18x equals 117. Therefore, x is equal to 117 over 18, which is equal to 6.5. Therefore, the height is equal to 13 plus 6.5, which is 19.5. For question 8, let's start by adding the ratio 9 plus 4 plus 2 is equal to 15. I'm gonna divide 600 by 15. This comes out to be 40. So the ratio T to C to D is 9 to 4 to 2. And I'm gonna multiply everything by 40. So I'll get 360 to 160 to 80. Now 45% of 360 is for yellow flowers. So 45 over 100 times 360 is equal to 162. Similarly, 5/8 of 160 are for yellow flowers. So 5 over 8 times 160 gives me 100. And all of the 80 are for yellow flowers. So I'm just going to write 80 here. Finally, just add 162 plus 100 plus 80, and this will give you 342. For question 9, I have an investment at the rate of 2.4% per year compound interest, and for a period of 4 years. So let's find the multiplying factor. This is equal to 100 plus 2.4, so 102.4 over 100 because it's a percentage, and then to the power of 4 because I have 4 years. As a decimal, this is 1.024 to the power of 4. So using the following formula, the final amount is equal to the initial amount times the multiplying factor. Put that in the calculator and you'll get a value of 4,948. For question 10, I'll multiply the second equation by 2. I'll keep the first one the same. So I will have 6x plus 4y is equal to 1, and 6x plus 10y is equal to 16. And now I will subtract the two equations, so the 6x will cancel out. 4y minus 10y is equal to minus 6y, 1 minus 16 is minus 15. So y is equal to positive 5 over 2. And I'm going to replace y into the first equation. So 6x plus 4 times 5 over 2 is equal to 1. So 6x plus 10 is 1. 6x is equal to minus 9. So x is minus 3 over 2. And those two are the final two answers. For part I of question 11, the two factors are x plus 11 and x minus 2. And if you set this equal to 0 and solve it, you get x equals minus 11 or x equals to 2. For question 12, I'll start with a table where the rows are the sum, n, and the mean, and the columns are 4 days, 3 days, and the total, which is 7 days. Obviously, when we are referring to 4 days, n is 4. Similarly, for 3 days, n is 3, and for 7 days, n is 7. Now, I'll transfer what I'm given in the question onto the table. So the mean for the 4 days is 11,800, and the mean for the 3 days is 13,207. To find the mean for the 7 days, I'll first need to find the sum for the 4 days, the 3 days, add them up to find the sum for the 7 days, and then divide to find the mean for the 7 days. So 4 times 11,800 comes out to be 47,200. For the 3 days, 3 times 13,207 is equal to 39,621. And the sum for the 7 days is equal to 47,200 plus 39,621. And this comes out to be 86,821. So the mean for the 7 days is 86,821 divided by 7, and this comes out to be 12,403. In part A of question 13, I need to complete the cumulative frequency table. So the first row is 7, then 7 plus 17 is 24, plus 18, 42, plus 14 is 56, plus 10, 66, and finally plus 4 is equal to 70. In part B, I need to plot the points and draw the cumulative frequency diagram. Here are the points, distance on the x-axis, cumulative frequency on the y-axis. Let's join them either with a smooth curve or using line segments. I'm going to go with method 2. For part C, I need to use the graph to find an estimate for the interquartile range of the distances. Now, first, I will calculate 70 over 4, which is equal to 17.5. Now, I will go on the graph and find that observation. That will be my first quartile. Then I'm going to calculate 3 times 70 over 4, which is 52.5, and that's the position. Again, I'll go on the graph and for that observation find the distance. So let's do that. Let's go to the graph, and for those values of the cumulative frequency, I will find the distance. So from the graph, I have two readings, one here which is 16 and one here which is 38. Let's write those down. 16, 38. Note that the mark scheme accepts a value for Q1 between 16 and 18, and for Q3 a value of 36 up to 38. So the interquartile range is the difference between Q3 and Q1, so 38 minus 16 which comes out to be 22 kilometers. The mark scheme accepts a value of 18 up to 22. For part D, I'm going to use the graph to estimate the number of teachers who travel more than 46 kilometers. So now I'm going to do the reverse. I'm going to go on the distance axis, locate 46 and find the corresponding cumulative frequency. So from the graph, I get a reading of 62, but these are the number of teachers that travel less than 46. I want more than 46. So it's my total 70 minus 62, which gives me an answer of 8. Note that the mark scheme accepts a value here, a reading of 61 up to 64. So a value between 6 and 9, but it has to be an integer. For part A of question 14, I will keep the 3y and expand the brackets. So 2y squared plus 14y plus 5y plus 35. Let's simplify now. 3y, 2y squared plus 19y plus 35. And now let's expand again. 6y to the power of 3 plus 57y squared plus 105y. For part B, I will make the denominators the same, and the lowest common multiple of the denominators is 100. So I'll multiply the first fraction by 20, second by 25, last one by 1. So I get 20 times 2x plus 3 plus 25 times 6x minus 5 is equal to 163. Now you can write the denominators if you want and then cross them out like this. But since we know they will be cancelled out, no need to write them down. So let's expand the brackets. 40x plus 60 plus 150x minus 125 is equal to 163. So if I collect all the x's to the left, I'll get 190x, and on the right 228. So x is 228 over 190, which simplifies to 6 over 5. For part A of question 15, I'll start by removing the square roots. So I get e squared is equal to 7g plus 5 over 11 plus 2g. Then I will cross multiply. E squared times 11 plus 2g is equal to 7g plus 5. Then I'll expand 11 e squared plus 2g e squared is equal to 7g plus 5. Next, I will collect all terms with a g to the left. So 2g squared minus 7g is equal to 5 minus 11 squared. Now I can take g as a common factor on the left. So g 2 squared minus 7 is equal to 5 minus 11 squared. And finally, I can divide by the bracket to get g on its own. So g equals 5 minus 11 squared over 2 squared minus 7. I'll start part B by factorizing. So 3y minus 8 times y plus 4 must be greater than 0. So my roots are y equals to 8 over 3 or y equals minus 4. A rough sketch will be useful here. So the region above the x-axis is the region in red, and this happens to the left of minus 4, so y is less than minus 4, or to the right of 8 over 3, so y is greater than 8 over 3. For question 16a, I'll start with the central region. So I have a 9 here. And then the region above, which is the knitting and photography, has 17 minus 9, which is 8. Now these two regions here are equal to 16. So this is 16 minus 9, which is 7. And these two regions here now are equal to 20. So 20 minus 9 is equal to 11. Now the whole of photography is 28. So to find this region here, just subtract 28 minus these three regions. So I get 28 minus the other three, 9 plus 8 plus 7, which gives me a 4. Similarly, this whole region is equal to 39. So just this region is equal to 39 minus 11 plus 9 plus 7, which gives a 12. Two students are outside the circles. To find this region here, use the fact that I have a total of 60 students. So 60 minus all the rest, which is 8 plus 4 plus 11 plus 9 plus 7 plus 12 plus 2. And this gives a 7, which is this region here. In part B, it says, given that a student takes photography, what's the probability that the student also chooses knitting? So let's go back to the diagram. I know that the student takes photography, so it's one of those students here, the 4, 8, 9, or 7. Out of those students, out of those 28 students, how many take knitting? And the answer is these students here, the 8 and the 9. So my answer will be 17 out of 28. For parts C and D, note this N in front of the sets. It means I want the number of students, not the probability. And for the first one, part C, P intersection K dash means I want P without the K. So let's go back to the diagram. P without K is this region here. So 4 plus 7 is equal to 11. And finally, for D, I want P union E and then intersection with K. P union E are all these numbers here, and I want the intersection of that with K. So I'm referring to these three numbers, 11, 9, and 8, which gives a total of 28 students. For question 17, I have Q equals the constant of proportionality times the square root of D. I'm going to substitute the pair of values I have in. 4.5 is equal to K times the square root of 324. So 4.5 over the square root of 324 is equal to K. Put that on the calculator. K comes out to be a quarter. So Q is equal to 1 over 4 square root of D. For question 18, I'll start by rearranging this equation to get y on its own. So 5y is equal to minus 2x plus 7. So y is equal minus 2x over 5 plus 7 over 5, which means that the gradient is minus 2 over 5. Then I'll use the following rule. So the gradient of a perpendicular line is equal to minus 1 over this gradient I just found, which is minus 2 over 5. If you do this calculation, you'll get 5 over 2, and that's the required gradient. For question 19, I'll start by finding the lower and upper bounds of C, F, and H. So C is between 7.5 and 8.5. F is between 6.615 and 6.625. And H is between 1.15 and 1.25. I want the lower bound for G. which means I want the lower bound of the numerator over the upper bound of the denominator. And now for the denominator, I have a difference. Therefore, I'll take the upper bound of the first number minus the lower bound of the second number. So I will need the 7.5, 6.625, and the 1.15. So if I replace these numbers into the equation, I'll get 7.5 over 2 times 6.625 minus 3 times 1.15. Now put that on the calculator, you'll get a value of 75 over 98. And as a decimal, this is 0.765 to 3 decimal places. For question 20, I'll start with 5k over x plus 2. Now we'll replace k with x minus y. So I get 5x minus y over x plus 2. Next step, I will replace the two x's with 1 over 4y. So I get 1 over 4y minus y over 1 over 4y plus 2. And now I will expand the bracket. So I'll get 5 over 4y minus 5y over 1 over 4y plus 2. And now I will multiply both numerator and denominator by 4y. So when I do that, I'll have some simplifications. The 5 over 4y times 4y will give me a 5 minus then 20y squared in the denominator. Similar simplification will leave me 1 plus 8y, and that's my final answer. For question 21, I'm given the area of the shaded region and I'm asked to find the diagonal of this square. Now let r be the radius of the circle. So each side of the square is equal to 2r. Now the shaded region is equal to the area of the square minus the area of the circle. So 80 is equal to 2r all squared minus pi r squared. So 80 is equal to 4r squared minus pi r squared. 80 is equal, and now I'm going to take r squared as a common factor. So r squared 4 minus pi. 80 over 4 minus pi is equal to r squared. So to find r, I'll just take the square root of this fraction. As a decimal, this is 9.65 and so on, but I have the exact value for future calculations. So now let's use Pythagoras theorem to find the diagonal. AC squared is equal to 2r squared plus 2r squared. This is 4r squared plus 4r squared, and simplifies to 8r squared. So this is 8 times that value I have on my calculator, 9.65 and so on squared. This comes out to be 745.5 and so on. So AC is equal to the square root of this number. Put that on the calculator and you'll get 27.3 centimeters. For question 22, I need to solve simultaneously those two equations. I'll proceed with substitution. I'll start with the straight line and I will rearrange to get y on its own. So now I can substitute that y with 5 minus x. So let's start. 2x squared plus 3, 5 minus x squared is equal to 110. 2x squared plus 3 times 25 minus 10x plus x squared is equal to 110. 2x squared plus 75 minus 30x plus 3x squared is equal to 110. Let's collect everything to the left hand side and simplify. 5x squared minus 30x minus 135 is equal to 0. Now I'll divide everything by 5. This will give me x squared minus 6x minus 27 is equal to 0. Let's factorize. X minus 9 times x plus 3 is equal to 0. So the two x values are 9 or minus 3. And I'm going to replace those two x values into this rearranged equation. So I'll get y is equal to minus 4 or y is equal to 8. So the two points of intersection are 9, minus 4 and minus 3, 8. For question 23, I'll start by writing 30, 25 and 180 as product of prime numbers. 30 is equal to 2 times 3 times 5. 25 is equal to 5 squared. And 180 is equal to 2 squared times 3 squared times 5 to the power of 1. So let's replace those numbers with the product of prime numbers. 2 times 3 times 5 times 5 squared to the power of 2x plus 7. And in the denominator, I have 2 squared times 3 squared times 5. Now the square root of that is the same thing as saying to the power of a half times 5 to the half and everything to the power of 4x plus 9. Now I will multiply these powers, these as well, and here the half applies to all three powers. The power of 5 is 1, so let's do that. So 2 times 3 times 5 times 5 to the 4x plus 14 over 2 to the 1 times 3 to the 1 times 5 to the half times 5 to the 2x plus 9 over 2. Now I can cross out the 2 with the 2 and the 3 with the 3 and I'll be left with 5s. Now here again the power is 1 and I will add these powers, the same with the denominator. So I get 5 to the 4x plus 15 over 5 to the power of 2x plus 5. And the last step is to subtract those two powers and I'll be left with 5 to the 2x plus 10, which is the final answer. For part A of question 24, I need to find vector AC. Now AC is equal to AO plus OB plus BC. Therefore, minus 4A plus 3B plus 2A plus B. And if you simplify this, you will get minus 2A plus 4B. Now on the next page, I'm given some extra information. So now I'm going to go to my diagram and extend lines BC and join OP and extend it to find point Q. Now AP to PC is 3 to 2. So AP is 3/5 of this distance and PC is 2/5 of the distance. Now OQ is a multiple of OP and BQ is a multiple of BC. So I'll find OQ in two different roots, and then I will equate those two roots. Before I do that, I'll need to find OP. So OP is equal to OA plus AP, which is equal to OA plus 3/5 of AC. This is equal to 4A plus 3/5 of minus 2A plus 4B. Let's expand. Is equal to 4A minus 6 over 5A plus 12 over 5B, which simplifies to 14 over 5A plus 12 over 5B. So let's now find OQ in two different ways. First, it's the direct one. OQ is a multiple of OP, so let's write lambda of OP. So lambda of 14 over 5A plus 12 over 5B. Let's expand. That's 14 over 5 lambda A plus 12 over 5 lambda B. So let's do the alternative now. So or OQ is equal to OB plus BQ, which is equal to OB plus mu times BC. So I get 3B plus mu times 2A plus B. Let's expand. 3B plus 2 mu A plus mu times B. And if I isolate the A's and the B's, I'll get 2 mu A plus 3 plus mu B. So now I can equate the coefficients of A. That's the one on the left. That's the one on the right. And I'll do the same with the coefficients of B. 12 over 5 lambda on the left. 3 plus mu on the right. So 14 over 5 lambda is equal to 2 mu. If I divide both sides by 2, I get 7 over 5 lambda equals to mu. And then from the blue relationships, I've got 12 over 5 lambda is equal to 3 plus mu. So now I can replace this mu with 7 over 5 lambda. So 12 over 5 lambda equals 3 plus 7 over 5 lambda. Let's take the lambdas to the left. 12 over 5 lambda minus 7 over 5 lambda is equal to 3. Now this will give me 5 over 5 lambda equals to 3. So lambda is equal to 3. So if I go back to OQ from the left approach, OQ is equal to 14 over 5 3A plus 12 over 5 3 times B. And if I simplify this, I will get 42 over 5A plus 36 over 5B, and that is my final answer. In question 25, I have two transformations on the sine graph. I have the plus 60, which is a translation by 60 units to the left. And I have the times 2, which is a stretch by a scale factor of 2 along the y-axis. In order to be able to make a comparison, I'll need to have a look at the original one. So let's go to the bottom of the page and have a look at it. Now the first maximum occurs at 91 and the cycle completes at 360. So after the two transformations, this point will move 60 degrees to the left, so it's gonna go to 30, and the height from 1 is gonna go to 2, so point A has coordinates 32. For point B, let's reapply this on this point. 60 degrees to the left will take it to 300. If you multiply the y's by 2, it won't affect the 0 because 0 times 2 is 0. So this point is 300, 0.